Alright, here we go. Now, to begin with, make you guys focus, Robbie. You're officially on the website now, so when parents look at it, they'll hear me yelling at you first. Alright, now, today's topic is going to be, oops, it's not going to be that. Converting grams to atoms. Now, quickly in review, that's going to be our title. Now, quickly in review, we've done a bunch of work, and basically the final step is putting it all together. And that's the last thing that we're going to do. And we're going to first take a look at some of the things that we've already done. For example, one of the things that we've already done is molar mass. So this is in review. One of the things we've already talked about is molar mass. Does anyone have any difficulties with molar mass? Any problems doing molar mass? You still have some problems? You want me to do an example? Okay. I'll try to keep it somewhat easy, but if I take MgCl2, what we need to do in this problem is we just need to figure out what is the molecular weight or the molar mass of MgCl2. And to begin with, we look at magnesium. How many magnesium atoms do we have in that molecule? One. And what's its mass? 24.31? Okay. Perfect. So I take 1 times 24.31 and I get 24.31, right? The next one is chlorine. How many chlorines do we have? 2. What's chlorine's atomic mass? 33.45? Okay. 33.45? It's what? 35. Oh, 35, okay. Oh, wow. That's special. Okay. Well, thank you, sir. Do you mind just put it right there for now? Thank you. All right, wow. 35.45, is that right? Ivy, Riley, is that what you guys got? Okay, good. Now, if you guys get your calculators out, if you don't have it out already, multiply 35 times 2, what do you get? 70.9? Okay. $35.45, sorry. My bad. I erased it and forgot to put it back in. Alright. 70.9 will be our answer. What we do next? Do you know what we do next? Sure do? We just add them, right? Okay. So when you add these two together, what do you end up getting? 95.21? Okay, so you end up getting 95.21. And what are the units that we use for molecular weight or molar mass? Grams over moles. That's molar mass. So all we're doing is we're calculating the amount of, for 1 mole of MgCl2, you would get 95.21 grams per mole. If you needed more help on this, that molecular weight worksheet that you guys are working on would help you. It's also entitled 10-1 worksheet that you guys did in class. That will help you with some of the practice. You've also seen it in the Cornell notes. It's also in your notes from a couple days ago. And so you can look at either one, and that will help you as well. Can we do it? Not right now, but I'd be glad to work with you if you want some more help on it. Part 2. We've gone from molar mass, and then we looked at how to convert that molar mass using it to turn grams of something into moles. We also learned how to take moles into grams. That was the second thing that we learned, and I don't have time right now to go through this with you, but after I'm done going through a new part of the lesson, I'll be glad to help anybody as we have time at the end of this. So the third part that we've looked at is we learned how to take moles and convert it to molecules or atoms. That's the third thing that we've learned so far in this unit. So we've looked at three different things: molar mass, conversions, and now the last thing that we are going to look at is the part of the lesson today that you guys need to know. And that's how to convert things from grams all the way to molecules now. And it's just doing all three of these steps. Putting what you guys have learned into play. If you don't get what we were doing today, on Monday we're going to spend a lot more time concentrating on just this, okay? So what I would like you guys to focus on are the individual parts that you've learned over the last 3 days. And I'll come around after we get done going through this little bit of a lecture, and we'll spend the time with you individually if you need it. But it is important, guys, to make up all the work over this weekend that you haven't finished yet. All right, let's do a practice run of this. Let's take 50 grams So we're going to take 50 grams of NaOH and we're going to convert it over to molecules of NaOH. Looking at what we've done, what do you think my first step should be? Little static feedback out there. What's the first thing that we've been doing almost every single time so far? No? The molar mass. Yeah. We have to find the molar mass of NaOH. And so, Monica, you want another example? This is going to be another example that we're going to do within this problem. All right. So, oops. Wow. Here we are, NaOH. We need to find out what we have for masses for each one. So, sodium. How many sodium atoms do we have in this problem? 1. What's its mass?
22.99.
Okay, so we take 22.99, multiply that by 1, and here's some tough math. It is 28, right? Just kidding. Okay, number 2, oxygen. How many oxygen atoms do we have? What's its mass? 1 times 16? 22, right? Good, okay. Just kidding, 16. 1 times 16. It's actually 16. Yeah, okay, good. All right, hydrogen. We have 1.01, 1.01. We add all these guys, these three together, some great calculator people. If you will help me out and tell me what is the overall mass of NaOH. Good, it's 40. So we got a total of 40 grams per every 1 mole of NaOH, right? So that's always our first step, find the molar mass. Does this make sense to you guys, how we find molar mass? It's okay? Just looking at the periodic table and then multiplying and adding and that kind of stuff. All right, so our next step is to actually do a conversion. So we're going to take 50 grams of NaOH. As I take the 50 grams of NaOH, I want to convert this over to, first, moles of NaOH. To do so, I'm going to use my dimensional analysis. Now, if I have grams up over here, 50 grams, what do you think needs to go down here to cancel out with the grams over here? The grams. So, what kind of grams do we have? 40 grams. Good. So we have 40 grams, they cancel out with these grams. Now, in terms of moles, what does 40 grams equal? 1 mole. There's our conversion. 40 grams equal 1 mole. These cancel out. I'm left with moles. If I were to take 50 divided by 40, what do you get for an answer? 1.25. Thank you. You then get 1.25 moles of NaOH. Now, I should probably be a little bit more careful. Instead of just putting 40 grams, I should put 40 grams of NaOH in there for every 1 mole of NaOH. Because each atom or each molecule is going to be a different number, right? So you want to make sure that we're clear that this is for NaOH that we're dealing with. All right, good. So step 1 is to do this. Step 2 here, we go to step 3. In step 3, we want to convert those moles to what we're actually looking for, which is molecules of NaOH. So I take 1.25 moles of NaOH. Now I have moles on top of here. What needs to go on down here to cancel out these moles? 1 mole. Or moles in general. 1 mole equals how many molecules?
6.02 times 10 to the 23rd.
Perfect. 6.02 times 10 to the 23rd. And I guess it doesn't really matter, but we will put this in on this situation, because later on it will matter. So we're saying for every 1 mole that there's going to be 6.02 times 10 to the 23rd molecules of NaOH, right? And that's going to be consistent for all the things that we do. And I forgot to put in there molecules. Hey, there we go. So now we are able to cancel out these moles, and what I'm left with is molecules of NaOH, right? Now, since this is on top, I multiply 1.25 times 6.02 times 10 to the 23rd, or do I divide it by 6.02 times 10 to the 23rd? Which one would it be? Multiply everything on top. So I'm going to do this one. But I highly recommend, guys, I'm doing this for accuracy's sake. I'm doing it for you. But I highly recommend that you do the math too to make sure you come up with the right answer. Most of you at this point know how to do this kind of problem. The problem is I'm not sure if you know how to put it in your calculator correctly. And that's going to be important. And you want to continue to test to make sure that you're doing it right as we're doing with these exponents. There's easier ways to figure this stuff out. When you guys do your CST test, you're actually not allowed a calculator, and there's ways that you can figure these things out. They'll keep it at whole numbers, so it makes it easy. But there's ways of figuring these out without using a calculator. But for our purposes now, calculator will work. So I got an answer 7.5 2 times 10 to the 23rd molecules of NaOH. You got that too? Good. If you got that answer, you know how to use your calculator right. And that's a key important part of this chapter. So a lot of people get stumbled and they mess up a lot just because they can't use their calculator right. Don't want to belittle that, but now there is one other way that we can do this. You can do it this way. We can step it up, by different pieces. So you calculate into moles, or you calculate into molecules next, or you can do one big equation. A lot of people like to do it this way. It's a little bit more simple, in terms of, let me rephrase that. It's a little faster, but it is not simpler. And that is, if you take 50 grams of NaOH, you do your first conversion the same. 1 mole NaOH for every 40 grams of NaOH. But instead of calculating at this point the number of moles, you can keep going on. You can say, okay, I'm going to do my next conversion. 6.02 times 10 to the 23rd molecules of NaOH over 1 mole of NaOH. Oh, shoot, there's our bell. Multiplying these things, and you will get the same answer. Alright. That's it. We were done anyway, so. We just didn't get to, we'll do the demonstration tomorrow. Or Monday.
Where are you going to upload it?
This? Oh, shoot, it didn't stop.